Hello everybody, this is Carmen Killed the Cat, and welcome to your 19th, I think, Lua 5.2 tutorial. In this video, we'll be going over the Bitwise Library, which is a feature that was added in Lua 5.2, so we didn't go over it in the old tutorial series. And I know I said last video that we'd be going over the string library, but I don't have much time today, and also I'm getting sick, so I don't really feel like recording a 2-hour long video, or probably more like an hour. But anyway, I don't want to record a long video right now, so I'm just trying to get something out this week. So let's get started. So the Bitwise library in Lua takes the place of the Bitwise operators in most other languages. So instead of single pipe for Bitwise OR, single ampersand for Bitwise AND, single caret for Bitwise exclusive OR, and whatever the language you're thinking of has for Bitwise NOT, it changes between languages. Lua replaces these with functions. So to use Bitwise OR, we could say print bit32, it's the name of the library, dot BOR, and as parameters we give it what would be on each side of the Bitwise OR operator in most languages. So we could say OX0 and OXF, and this should give us 15. If we were to replace this with two OXFs, we'd still get 15. So that is the Bitwise OR operator. I'm not going to tell you what each of these operators do. You can just Google them if you don't know what they do, but it shouldn't be too hard to find. So bit32.band, give it OX0 and OXF again, and we get 0 there, but if we change this to OXF as well, we would get OXF. Or we change this to OXA, and we would get 10. So we'll leave this like that. Then Bitwise exclusive OR is bit32.bxor, and we'll give that OX0 and OXF, and we get 15. And then Bitwise NOT is bit32.bnot, and we will give this OX0, and we get I think that's 2 to the 32 from that. So it just inverts all of the bits in the number. So that is max for a 32-bit number. So those are all of the basic Bitwise operators, and any of these functions, BOR, BAND, and BXOR, can take any number of parameters, and it will just apply the operation in the function to each of the parameters. So it doesn't matter which order you put them, they're all commutative and dissociative, so that's why the functions can all take multiple parameters. The next few functions are the right shift, left rotate, and L rotate, so, or left rotate. So if we print bit32.lshift, this is the equivalent of left shift and right shift, and there's no rotate functions in most languages. So left shift just shifts all the bits to the left, so we can give it OXF, and we get an error. Oh, we need to tell it how many times to shift. We'll say 2. We get 60, and we can print bit32.rshift, give it OXF and 2. Should do the opposite. We get 3, and then bit32.lrotate, OXF, and we will give it 2 again. We get 60, and then bit32.rrotate with OXF and 2 gives us a large number. I'm not sure what that would be in hexadecimal, but it rotates it right by 2. And then there's also AR shift, which is arithmetic shift, which shifts the bits, and instead of replacing all newly created bits with that were shifted out of with zeros, it replaces it with the signal bit. So bit32.rshift OXF and 2, and we get 3. So it does the same thing in that case. So the Bitwise library also has 3 convenience functions for you to use. The first one is btest, so you can say print bit32.btest, btest. There we go. And this does the same thing as b-and, except it returns true if the result isn't 0 and false if the result is 0. So you can say OXF and OXF. And run this, and we get true. But if we were to give it OXF and OX0, we would get false, because the result of this is 0, and the result of OXF and OXF is not 0. So this is just kind of a Boolean operator that does the same thing as b-and. So the next one is called extract. So print bit32.extract. And what this does is it allows you to extract some amount of bits from a number. So we can say, as a first parameter, we have the number. Say OX, A, B, C, D, E, F. And as a second parameter, we give it where we want to start extracting the bits. So we'll say at position 4. And the third parameter is how many bits we want to extract. So we'll give it 8, and that will be 2 hexadecimal numbers. So when you're indexing with this parameter, it's kind of weird. It starts at the least significant bit, so it starts at the right and then goes to the left. It kind of seems logical if you don't know much about bitwise operations for it to go or start at the left and go right, but it starts at the right and goes left, least significant bit to most significant bit. So this should extract E and D, so it should give us OXDE. So we can test that. We can just print OXDE and see if the values match. And we run this, and they're both 222. We could also only extract 4 bits, and now we should only get E. Values still match. We could extract 12 bits, and we would get CDE. Values still match. So it extracts whatever bits you tell it to with these parameters, and returns them as a number. The third function is bit32.replace, and this is almost the opposite of extract. So bit30, or we can print it. Print bit32.replace, and we'll give it the same number. So OX A B C D E F, and this also takes a number that you want to replace. So we'll give it OXFF. And then the second parameters are the same. We'll say 4 and 8. There are 8 bits to replace here. So what this will do is, instead of extracting the bits that you specify with this index, it will replace those bits with the number you give it here. So this should, and I'm pretty sure it returns this number after the replacement. So if we run this, we get a big number. So let's print what the result should be. OX A, B, C, FFF. These should match, and they do. So the replace function replaces whatever bits you specify, in this case, this set of bits, this set of bits, with the number you specify here. So it replaced DE with FF. So those are all the convenience functions in the Bitwise library, and that's actually the whole Bitwise library. So that's all for this video. It was another short one. I'm sorry I didn't have much time today. So I'll see you in the next video where we will do the string library.